Hi, my name is Alexandra Hoya from ECE41 and this is my summative assessment for Internet of Things laboratory subject. Hi, so for summative assessment 1, final period in Internet of Things laboratory subject, this is the assessment. So the instructions, program the Raspberry Pi to carry out the task being asked as shown below. Submit the code using Python or Node-RED programming. So the problem is that we need to do or we need to solve using Raspberry Pi and Python code. Once PB1 is pressed or button 1, sequence 1 will commence and it will run for 10 seconds. Then it proceeds to sequence 2 for 5 seconds and again and loops back again to sequence 1. Hence, it repeats the process. So this is sequence 1. So there are 1, 2, 3, 4, 5, 6, 7, 8 LEDs. So sequence 1 from here to here will have 10 seconds. So if we're going to divide that, each LED will have a delay of 1.25 seconds. And back, sequence 2 from here to here, the sequence should be within 5 seconds. So if we are to divide that with 8 LEDs, the sequence should have 0.625 second delay. So let's do that in our Raspberry Pi and let's see the results. So for the results of summative assessment for Internet of Things laboratory, this is the code. So here I've imported RPI GPIO as GPIO. Also, I imported sleep from time library. This is for the time delay that we will be using in the code. So the code starts with us setting up the mode for the GPIO as BCM GPIO numbering. Also, the code uses warnings there and set warnings false. Next is the setup for the pinouts or GPIO pinouts for our circuit. So it used pins 2 for the in and pull underscore up underscore down equals GPIO PUD underscore down. This is for the button that we're going to use, the input. And also, of course, the output pins for the GPIO we used 5, 6, 13, 19, 26, 16, 20, 21. Those are the GPIO pins that we used for our LEDs. LED 1, 2, 3, 4, 5, 6, and 7 and 8. And count is equals to 0. Next, for the output, here we can see that pin 5 is off initially and 6 is off. All the LEDs are off up until we press the button. So this is the message that will appear in our serial monitor here. There. So again, all LEDs are off. This is the code for that up until someone pushed a button. So if GPIO.input 2, again, let's recall 2. 2 is for the GPIO in or for the button. So if 2 is false, so again, that means that if it is pressed, so it will sleep for 0.5 seconds. Count plus equals 1, it will print the count. So if count again is 1, so meaning that here, if the button will be pressed, then 1, then count will be equals to 1, and then the first sequence will start. So the sequence is outputs the output for the LEDs. So again, our LEDs are in the GPIO pins 5, 6, 13, 19, 26, 16, 20, and 21. These are the LEDs here, as you can observe. So there, this is the sequence. So let's observe the sequence later. Now moving on, this is the sequence 2. For the sequence 2, the code from the last LED here, this will be the first one to light up and decrease in order. So from 21, it will then go back to 5, or the first LED, but in a faster rate, which is 625 seconds. So here, the delay is 1.25 for the 8 pins. This is to have a sequence of 10 seconds from right to left. And this one, the reason why it's 0.625 is for it to have a sequence of 5 seconds from left to right. So this one is increasing 10 seconds from right to left, and this one is 5 seconds from left to right. So for the results of our experiment, let's click on run. So let's check if our code works when we use it in our circuit. So let's click on run. So we're asked in our serial monitor to press push button to start LED sequence loop. So let's do that. We're about to expect a 1.25 second delay in our 8 LEDs to fill up a 10-second sequence going from here to here, and 0.625 interval for a 5-second delay back. So there, that should be 10. After 10 seconds, 5 going back.